In this video, we're going to talk about psychosis. Now, psychosis encompasses a variety of diseases, including that of schizophrenia. Psychosis is loss of contact with reality. 12 to 23% of people experience a psychotic symptom at some point in their lives, but less than 4% meet the criteria for a psychotic disorder, and this is, of course, in the DSM. So what features do we see in someone who has psychosis? Well, there are 4 cardinal features or clinical manifestations. These are delusions, hallucinations, thought disorders, agitation, and aggression. So what do these mean? Well, let's look at delusions, hallucinations, and thought disorder or thought disorganization in more detail. So delusions are defined as strongly held false belief that are not typical of the person's background or culture. Further, delusions can be categorized based on its plausibility. So delusions can be bizarre or delusions can be non-bizarre. A bizarre delusion, an example of that is the person thinks that their family member has been replaced by someone else. And then a non-bizarre delusion is something like the person thinks that their partner is cheating on them. So it's not as bizarre, if that makes any sense. And then you have hallucinations. Now, hallucinations is defined as a wakeful sensory experience of content that is not actually present. And sometimes hallucination and illusions are actually used interchangeably, but they're different. Because, again, hallucination is a wakeful sensory experience of content that is actually not present. And illusion is actually distortion or misinterpretation of real sensory stimuli. And then you have thought disorganization, and these are just disorganized patterns of speech, and they include a lot of things, but I can't really go into it in detail, but these are just some of them. Alogia, thought blocking, loosening of association, conjectuality, clanging, word salad, and perseveration. So we see these things in a person who has psychosis, but not everything. And psychosis occurs or is caused by a primary disease or a secondary disease. So what I mean by this is primary disease is more of a mental illness, and secondary is attributed to an underlying disease. So some illnesses with psychosis, so the primary disease, include schizophrenia, schizophreniform disorder, schizoaffective disorder, delusional disorder, schizoteal personality disorder, and then we have substance abuse. So these are the primary illnesses with psychosis. Then you have secondary psychosis, and this is again attributed to an underlying disease such as thyroid disease, adrenal disease, hepatic encephalopathy, Wilson's disease, Alzheimer's disease, Huntington's disease, and stroke. So what changes actually occur in the brain to make someone experience psychosis? So now let's zoom into the brain and look at the areas affected in a person's psychosis. So the 2 main areas I want to introduce, the limbic system and the frontal cortex. And the actual names, I'll just use abbreviations first. These are in the limbic system, the VTA and the NAC. And then you have the prefrontal cortex, PFC here. And the 2, I guess you can say, neuronal pathways affected in someone who has psychosis. You have the mesocortical pathway, which is a pathway from the VTA here to the prefrontal cortex. And then the other pathway that is affected is the mesolimbic pathway. So that's between the VTA and the NAC. So let's just go to it in a bit more detail, beginning with the mesolimbic pathway. So here is the NAC, known as a nucleus accumbens. And here is a neuron that travels from the VTA to the NAC, to the nucleus accumbens. So 60% of neurons in the VTA are dopaminergic, and it is controlled by GABAergic neurons. So usually there's GABA neurons that are controlling this neuron I drew here. And this neuron is a dopaminergic neuron which will release dopamine to the nucleus accumbens. Now in psychosis, you actually have this neuron releasing so much dopamine. So if we were to look into the synapse between these two, we can see here is the NAC, the neuron of the NAC, and then here's the neuron of the VTA, and the VTA neuron is releasing dopamine, DA. And it is in psychosis, there's a lot of dopamine being released in the synaptic cleft. With a lot of dopamine in the synaptic cleft, it will bind onto the receptors, the D2 receptors, the dopamine 2 receptors. And as a result, the people will have the positive symptoms. And these include delusions and hallucinations. So positive symptoms is essentially something that is exacerbated in the person. So a person who has psychosis has positive and negative symptoms, as we will soon find out. And so the positive symptoms are delusions and hallucinations, and it is attributed to the increase in dopamine between the VTA and the NAC. So what happens in the mesocortical pathway? Well, the mesocortical pathway is again between the VTA and the prefrontal cortex, the PFC. So this neuron is traveling from the VTA to the PFC. And this neuron, as we learned, is a dopaminergic neurons because 60%, most of it are dopaminergic neurons. So this neuron will release dopamine into the synaptic cleft, and the dopamine will bind onto the prefrontal cortex. However, in the mesocortical pathway, we actually have low amounts of dopamine in a person with psychosis. So if we were to zoom into this area, in someone who has psychosis, here I'm drawing the VTA and the PFC, the connection, you actually have low amounts of dopamine being produced and secreted. And so there's low amounts that will bind onto the receptors here. The receptors here are D1 receptors, unlike the D2 receptors in the mesolimbic pathway. And so as a result of this decrease in dopamine in the mesocortical pathway, the person develops negative symptoms. And the negative symptoms include ovulation and flattening in affect. So essentially it's decrease in social abilities and sort of sadness. So I hope those changes made sense in a person who has psychosis. So you have, again, changes in the mesolimbic pathway, and then you have changes in the mesocortical pathway. So what are the treatments for someone who has psychosis? Well, essentially all antipsychotics are dopamine 2 antagonists. Now these dopamine 2 antagonists can be classified as first generation, known as typical, and this just means that they were made first. And then you have second generation, which is atypical. Then second generation can be classified further because most of the second generation are D2 antagonists, but they also can target serotonin receptors. So they could be serotonin 2 antagonists and serotonin 1 agonists. And don't be confused by all that. Just know that there are two types of antipsychotics. There are first generation and second generation. And the second generation targets other receptors as well, which are the serotonin receptors. So let's look at where these antipsychotics will have an effect. Remember the mesolimbic pathway, we have an increase in dopamine in the synaptic cleft here, and that they will bind onto D2 receptors. So essentially the antipsychotics will inhibit the D2 receptors and thus inhibit or stop the positive symptoms coming alive. And then some antipsychotics can actually work on inhibiting dopamine being released into the synaptic cleft here as well. So I hope you enjoyed this video. I hope it made sense. Thank you.